A line of grey eucalyptus trees stands along a ridgeline under a pale morning sky. Wind moves through the canopy, dry grass rustles against basalt stone, and a dirt track cuts straight across the crest without turning. There are no signs, no markers, and no visible breaks in the earth. Yet beneath this ridge, the crust of the continent has been severed, stacked, and pushed 60 kilometres out of position. What appears to be an unbroken mountain range is actually a giant structural dislocation covering tens of thousands of square kilometres. For more than a century, early surveyors mapped these ridges as simple granite uplift, completely unaware that the oldest rock layers were sitting directly on top of stone hundreds of millions of years younger. How did the quietest continent on Earth build a mountain system that silently inverted its own geological crust? Before this video ends, we will examine an underground river that vanishes into an unmapped cave system in the snowy mountains, and a peak where coordinates shift by meters because the land beneath it is moving. For generations, geologists assumed the Great Dividing Range was a simple, ancient spine created by gradual uplift along Australia's eastern margin. It was a reasonable assumption for its time. The peaks are rounded and weathered. But when systematic mapping began in the mid-20th century, that quiet surface began to fracture. Fact 50. The mountains stack their rocks backwards. Deep within the Lachlan origin of eastern Australia, sedimentary layers break the fundamental law of superposition. In normal geology, younger sediments settle on top of older ones. But along the Gilmore Fault Zone in New South Wales, ancient Ordovician turbidites, formed over 450 million years ago, sit directly on top of younger Silurian and Devonian strata. This reversal was caused by extreme thrust faulting during the Benambran orogeny, when massive horizontal compression shoved deep oceanic crust over younger continental margins. Fact 49. That inverted rock travelled over 100 kilometres to reach its present location. The upper crust did not merely lift, it slid horizontally across detachment planes. Geologists from Geoscience Australia estimate that entire structural blocks within the Lachlan Fold Belt migrated up to 110 kilometres eastwards during major tectonic collisions. The mountains standing today are the compressed, crumpled remnants of an ancient ocean floor shoved onto the edge of the continent. Fact 48. The iconic blue haze hanging over the Blue Mountains is entirely chemical. The mist that blankets the Jamison and Megalong valleys is produced by dense stands of Eucalyptus piperita and Eucalyptus oreades releasing volatile organic compounds, predominantly alpha-pinene and eucalyptol, into the atmosphere. When sunlight hits these organic aerosols, Rayleigh scattering deflects shorter blue light wavelengths, creating a blue atmosphere across the canopy that traditional owners, the Gundungurra and Darug peoples, have observed for thousands of years. Fact 47. You can walk on stone that predates complex animal life. In the Kapiti Valley, exposed basement rocks of the Williama supergroup date back more than 1.6 billion years. These ancient gneisses and schists formed during the assembly of the Columbia supercontinent, long before the Cambrian explosion filled the oceans with complex organisms. Fact 46. The mountains sit on a 6-kilometre deep stack of ancient mud. Most of the southern highlands are composed of the Adaminabi group, an immense layer of marine quartz sandstone, siltstone, and black slate. Laid down in a deep oceanic trench between 480 and 450 million years ago, this sedimentary sequence measures over 6,000 metres in thickness. Every high peak from Mount Bogong to the Brindabella Range was originally silt washed off a forgotten landmass that eroded away hundreds of millions of years ago. Fact 45. Detrital zircon grains confirm the foundation rocks are older than multi-celled fossils. Isotopic dating conducted by researchers at the Australian National University on zircon crystals within the Waganga group has yielded uranium-lead ages exceeding 530 million years. These tiny mineral grains lock in their creation age at the moment of magmatic cooling, proving that the bedrock beneath eastern Australia was already ancient when the first hard-shelled creatures appeared in the oceans. Fact 44. These weathered ridges once rivaled the modern Himalayas in height. During the Alice Springs orogeny, approximately 300 million years ago, crustal thickening along the eastern Australian margin pushed peaks to estimated elevations exceeding 6,000 metres. Over hundreds of millions of years, relentless denudation sawed off kilometres of rock, transporting the sediment westwards into inland basins and leaving only the roots of the ancient range. Fact 43. Geological windows expose hidden ancient limestone valleys. In places like the Yarrangobilly Valley, erosion has chewed through hard upper volcanic sheets to reveal underlying Silurian limestone beneath. Known geologically as a fenster or window, these flat karst pockets feature rich, calcium-dense soils that support entirely different ecosystems than the surrounding acidic sandstone ridges. Fact 42. You can stand on the exact line where two geological eras collide. At the Shoalhaven Gorge, the contact zone of the Shoalhaven Group sits directly against folded Ordovician basement rock. There is no gradual transition. A hard, horizontal boundary marks a gap in the geological record of over 150 million years, where an ancient land surface was submerged and capped by marine sediments. Fact 41. High-elevation plains remain completely tree-free for reasons science still debates. High-altitude grasslands like the Bogong High Plains and Barrington Tops feature open, treeless meadows at elevations where subalpine eucalypts otherwise thrive. Cold air pooling and severe winter thermal inversions trap freezing air in these hollows, creating frost pockets so intense that tree seedlings cannot establish. Fact 40. 80% of regional atmospheric haziness stems from natural biogenic emissions. Observations conducted by CSIRO and the Bureau of Meteorology confirm that organic terpene compounds emitted by native forest canopies account for 4/5 of light scattering across the Great Dividing Range. The remaining fraction, historically linked to industrial sulfur dioxide, has declined sharply over recent decades due to environmental regulation, returning seasonal atmospheric visibility towards baseline pre-industrial conditions. Fact 39. This region forms one of the most biodiverse temperate zones on the Australian continent. Marine sedimentary basins, volcanic plugs, and alpine plateaus host thousands of mapped plant and animal species. Researchers at the Australian Museum estimate that tens of thousands of invertebrate and fungal species within these mountain ecosystems remain formally unclassified by modern science, preserved through environmental stability stretching back to the last glacial maximum. Fact 38. These humid mountain gullies represent a global stronghold for terrestrial amphibians. Dozens of frog species inhabit the wet leaf litter of the eastern ranges, including rare stream-dwelling species like the Burralong frog. In terms of biomass per hectare, nocturnal amphibians in sheltered moist microclimates often outweigh the combined mass of native arboreal mammals living in the same forest canopy. Fact 37. Field biologists continue to uncover completely unmapped species inside long-established national parks. Taxonomists utilizing genetic sequencing routinely discover cryptic species hidden within familiar populations. Recent DNA analysis conducted by Australian university teams revealed that what was long catalogued as a single, widely distributed mountain frog species actually consists of distinct, isolated evolutionary lineages confined to single high-altitude valleys. Fact 36. Native bioluminescent beetles execute synchronized group flashing in dense rainforest gullies. During early summer breeding cycles, species of Luciola fireflies aggregate in dark gully systems across northern New South Wales and southern Queensland. Thousands of individuals flash in coordinated intervals of less than a second to signal across dense undergrowth, creating synchronized light displays across the forest floor. Fact 35. Access to delicate breeding corridors is strictly regulated to protect fragile nocturnal habitats. Environmental agencies limit public entry into key rainforest reserves during peak bioluminescent activity to prevent habitat disruption. Permits are allocated through balloted reservation systems to cap visitor footprints, balancing scientific monitoring against soil compaction and light pollution. Fact 34. Dual naming initiatives are restoring First Nations place names across the Eastern Highlands. Modern mapping frameworks published by state geographical names boards increasingly prioritize original Indigenous names alongside colonial labels. Prominent summits across the Snowy Mountains and Victorian Alps now carry their traditional ancestral titles on official topographic maps, reflecting tens of thousands of years of First Nations connection to country. Fact 33. Mount Kosciuszko stands as the highest point on the Australian continent at 2,228 metres above sea level. Sitting on the main range of New South Wales, its granite dome forms the apex of the Australian Alps. Unlike the sharp, glaciated peaks of other continents, Kosciuszko's gentle relief is the result of hundreds of millions of years of subaerial weathering, making it one of the easiest continental highest points to ascend on foot. Fact 32. A concrete geodesic observation structure was constructed atop the high alpine ridgeline in the mid-20th century. Built during the expansion of alpine tourism and weather monitoring networks, high-altitude research stations were established across the main range to record cosmic ray activity, meteorological data, and atmospheric conditions. From these elevated points, on clear days, visibility extends over 100 kilometres across the Australian Capital Territory and Victoria. Fact 31. The highest summits host isolated pockets of relict alpine vegetation dating to the last ice age. Above the tree line at 1,850 meters, specialized plant communities such as feldmark, herb fields, and snow gum woodlands survive in microclimates that resemble cold subantarctic environments. As lowland temperatures rose thousands of years ago, these cold-adapted species retreated uphill, leaving them stranded on high-altitude island peaks surrounded by warm inland valleys. Fact 30. Conditions on the elevated alpine plateaus technically qualify as high-altitude subalpine wetlands. Annual precipitation in the snowy mountains exceeds 1,800 millimeters, much of it falling as winter snow and dense summer fog. This persistent moisture feeds expansive sphagnum bog complexes that store millions of liters of water, slowly releasing it into the headwaters of the Murray, Murrumbidgee, and Snowy River systems throughout the dry summer months. Fact 29. An introduced pathogen has devastated native subalpine forest stands across the high country. Phytophthora cinnamomi, an invasive water mold, along with severe recurring bushfires, has caused widespread dieback in high-altitude snow gum forests. Trunks killed by disease and intense fire stand as grey skeletons along ridgelines, though ongoing regeneration surveys indicate resilient rootstocks are slowly pushing new growth through the soil. Fact 28. High-altitude weather conditions have claimed military and civilian aircraft across the high ridges. In November 1938, the Australian National Airways Stinson airliner crashed into the dense rainforest of the McPherson Range during severe turbulence, triggering a famous search operation. Debris from mid-century aviation accidents remains scattered across isolated mountain gullies, preserved by cold temperatures and thick vegetation cover. Fact 27. Australia's highest historic accommodation buildings relied on pack horses and physical haulage for basic supplies. Built in the early 1920s to support seasonal grazing and early skiing expeditions, structures like Seaman's Hut were constructed from local fieldstone on isolated saddles. Standing miles from sealed roads, these shelters saved lives during sudden summer blizzards and continue to serve as emergency refuges today. Fact 26. The mountains formed when ancient landmasses collided to forge the supercontinent of Gondwana. Between 500 and 300 million years ago, a series of island arcs and ocean trenches were crushed against the eastern margin of the Proto-Australian Craton during the Lachlan and New England orogenies. This tectonic compression folded marine sandstones, injected massive granite batholiths, and created the foundational bedrock of the modern continent. Fact 25. Isolated mountain saddles harbour over 100 rare and threatened plant species in single localized catchments. Places like the Mount Buffalo Plateau contain unique granite endemic species adapted to thin soil, severe frosts, and summer drought. Without targeted weed control and ecological management by park authorities, invasive plant species would rapidly encroach on these fragile high-elevation herb fields. Fact 24. The snow country receives higher annual precipitation than vast stretches of the coastal interior. NASA and Bureau of Meteorology satellite records confirm that mountain crests intercepting moist maritime air masses trap up to 2 meters of liquid. On a single alpine ridge, botanists can identify more distinct plant species than exist across entire northern European regions. Fact 21. Certain black slate formations across the range contain high concentrations of iron sulfide minerals, known as acid-bearing rock. Exposed beds of pyritic slate undergo chemical oxidation when broken open and exposed to air and water, generating natural sulfuric acid runoff. While undisturbed underground, this rock remains inert, but exposing it during infrastructure projects poses severe environmental risks to mountain streams. But what happens when modern civil engineering cuts directly into these chemical formations? Fact 20. Road construction exposed pyritic slate, triggering severe stream acidification in the Snowy Mountains. During the 1960s, construction of access corridors for the Snowy Mountains hydroelectric scheme, cut-and-fill operations sliced into the sulfidic slate beds near Cooma. Subsequent rainfall generated acid mine drainage, dropping local stream pH levels from 6.7 down to 4.7. This 100-fold increase in acidity, combined with dissolved heavy metals, rendered the stream uninhabitable for native galaxious fish along an 8-kilometre stretch for over a decade. Fact 19. One of the world's most isolated seismic tracking stations is concealed in limestone caverns near Canberra. Deep within the Silurian limestone formations of the southern highlands, subterranean seismometers record crustal vibrations with minimal surface interference. Upgraded during the Cold War era and currently monitored by Geoscience Australia and the Comprehensive Nuclear Test Ban Treaty Organisation, the station picks up regional intraplate quakes and distant underground nuclear tests across the globe, transmitting real-time telemetric data to international monitoring centres. Fact 18. Eastern Australia sits atop an active, recurring intraplate earthquake zone. The Eastern Australian seismic zone stretches over hundreds of kilometres along the Great Dividing Range, generating regular low-magnitude quakes. Unlike plate margin quakes, these intraplate events occur deep within continental crust due to far-field stress built up as the Australian plate drifts northeast at roughly 7 centimetres per year. In 1989, a magnitude 5.6 intraplate quake struck Newcastle, demonstrating that this ancient, supposedly dormant shield retains significant tectonic stress. Fact 17. New South Wales holds thousands of mapped karst systems and limestone caves. State geological surveys have catalogued over 8,000 cave entrances across the eastern limestone belts, including famous networks at Jenolan, Wombeyan, and Urangabilly. Formed within Ordovician and Silurian limestone by slightly acidic groundwater dissolving calcium carbonate along fault plains over millions of years, these subterranean conduits continue to yield new chambers when surveyed using modern three-dimensional laser mapping. Fact 16. Subterranean rivers cascade through massive underground chambers beneath the karst plateaus. Inside the Urangabilly cave network, underground streams flow through dark limestone caverns, feeding subterranean waterfalls that drop tens of meters into submerged sumps. Hydrogeologists using fluorescent dye tracing have mapped these invisible watercourses, proving that surface streams routinely disappear into sinkholes, flow for kilometers through solid rock, and re-emerge in entirely different river catchments. Fact 15. Cave networks across national parks are periodically restricted to protect native bat roosts. State national parks agencies restrict public access to sensitive cave systems to protect breeding colonies of the vulnerable eastern bent-winged bat and prevent the spread of fungal pathogens like white nose syndrome. Biologists monitoring cave microclimates rely on thermal imaging cameras and acoustic bat detectors mounted at cavern entrances to track population health without entering delicate roosting chambers. Fact 14. Deep vertical drop caves in the southern highlands require advanced technical survey methods. Pit caving networks, such as the deep shafts in the Mount Amber region, drop vertically over 100 meters into total darkness. Speleologists using three-dimensional LiDAR scanning and line survey techniques have mapped intricate multi-level systems, establishing that large portions of Australia's subterranean karst remain completely unmapped by standard surface cartography. Fact 13. Australia's largest hydroelectric project flooded mountain valleys and submerged historic townships. Completed in 1974, after 25 years of continuous construction, the Snowy Mountains hydroelectric scheme constructed 16 major dams, including the 162-metre-high Talbingo Dam. The resulting reservoirs impounded millions of gigalitres of water to power hydroelectric generators and divert river flows westward for agricultural irrigation, permanently altering the hydrology of the Murray-Darling Basin. Fact 12. An unfinished infrastructure project created a mountain road that abruptly terminates in wilderness. Following the flooding of the Yucumbene Valley, replacement road projects along the lake margin were halted mid-construction due to environmental constraints and ballooning costs. A sealed two-lane road terminates at a concrete tunnel entrance overlooking open water, remaining as a physical remnant of mid-century engineering realignment. Fact 11. Severe winter drawdowns expose drowned historic towns beneath storage reservoirs. When water levels in Lake Yucumbene and Lake Jindabyne drop during prolonged droughts, the concrete foundations, stone fence lines, and bridge abutments of Old Adaminaby and Old Jindabyne re-emerge from the mud. Relocated in the 1950s before the valleys were flooded, these drowned townships become visible again, allowing former residents to walk original street grids preserved under sediment for decades. But what happens when an entire mountain community vanishes, not under rising water, but into the forest itself? Fact 10. An abandoned mountain mining hub lies completely swallowed by temperate forest inside national park boundaries. Walhalla, located in Gippsland, Victoria, grew rapidly following the discovery of the Cohen's Reef gold vein in 1865, eventually housing over 4,000 residents. When major underground mining operations ceased in 1914, the township depopulated within years. Today, timber cottages and stone retaining walls sit overgrown along steep valley sides, monitored by Parks Victoria as historic heritage structures amidst dense eucalyptus regrowth. Fact 9. Australia's most visited national parks operate with complete free public entry under historic land deeds. The Royal National Parks and State Reserves along the eastern seaboard record tens of millions of recreational visits annually. Under original 19th century park gazettal covenants and state crown land agreements, standard pedestrian and vehicle access across major thoroughfares like the Grand Pacific Drive remains free of tolls. forcing management agencies to rely on parking permits and commercial licenses to maintain track infrastructure. Fact 8. Native megafaunal species were exterminated from the eastern highlands, then systematically reintroduced. The eastern grey kangaroo and swamp wallaby populations collapsed across large sections of the southern tablelands during 19th century agricultural expansion. Through coordinated reintroduction programs established by state fauna authorities, wild populations were re-established in protected valleys like Tidbinbilla, where herbivore grazing now actively regulates subalpine seedling growth and understory fuel loads. Fact 7. High-elevation national parks protect the highest density of native marsupial carnivores in the country. Reserves spanning the Great Dividing Range shelter stable populations of the spotted-tailed quoll, Australia's largest mainland native carnivore. Capable of climbing rainforest canopies, these solitary predators require contiguous tracts of unfragmented forest exceeding 500 hectares per individual, making protected mountain corridors vital to their survival. Fact 6. A timber exploitation boom completely eliminated iconic native trees across millions of hectares. The Australian native forest ecosystem suffered catastrophic loss following European settlement when clearing and logging decimated prime stands of red cedar, Tuna ciliata, along coastal river valleys. Known as red gold, mature specimens reaching 60 meters in height were logged to near extinction by the late 19th century, leaving only isolated regrowth trees in inaccessible mountain gorges. Fact 5. The highest waterfalls along the eastern escarpment drop hundreds of meters over basalt cliffs. Wollomombi Falls in the New England National Park drops a total of 220 meters into a granite gorge, making it one of the tallest single drops in Australia. Fed by upper plateau catchments, these escarpment waterfalls illustrate how persistent headwood erosion slowly carves into the eastern edge of the continent, cutting back the tablelands kilometre by kilometre. Fact 4. Marine fossils embedded in alpine limestone confirm the peaks were once a shallow sea floor. At elevations exceeding 1,200 meters in the Urangabili and Abercrombie caves, rock faces contain fossilized crinoids, rugose corals, and brachiopods dating to the Silurian period, 430 million years ago. These marine organisms lived in warm equatorial waters before tectonic plate drift and crustal thickening pushed the entire rock assembly 2 kilometers into the air. Fact 3. Deep intraplate faults beneath the mountain range remain active over geological timescales. Geomorphological surveys conducted by Geoscience Australia reveal fault scarps along the Lake George and Cadell faults that have shifted during the Quaternary period. Trenching studies indicate that these intraplate faults have produced magnitude 6 or higher earthquakes within the last 20,000 years, proving that the continent's internal stress field continues to deform the surface. Fact 2. Modern satellite positioning confirms these ancient mountains are actively rising. High-precision global navigation satellite system monitoring networks operated by Geoscience Australia show that sections of the southeastern highlands are undergoing vertical uplift at rates of roughly 0.5 millimeters per year. Driven by mantle convection and far-field tectonic compression, this subtle upward force counters continuous erosion, quietly regenerating the continent's eastern spine. But what is the single most remote, untouched location left in these ancient mountains? Fact 1. Deep in the Jagungal Wilderness sits one of the most geographically isolated points in eastern Australia. Located inside Kosciuszko National Park, this point lies more than 9 kilometres from any marked trail or vehicular access track. Reaching it requires navigating steep granite gorges, dense subalpine heath, and unmapped gully systems. Threading through this wilderness are faint historical stock routes and bridle trails used by high country graziers before the national park was gazetted in 1944. These tracks do not appear on standard modern topographic maps, yet they remain etched into the landscape, slowly being swallowed by regenerating snow gums. In the most thoroughly mapped mountain range on the continent, vast pockets of high country remain almost completely unvisited. What kept this hidden structural reality obscured for so long was not a lack of physical inspection, but the sheer scale of the geological timeline itself. Early colonial cartographers looked at these mountains through the lens of young European landscapes, expecting dramatic glacial horns and active volcanic cones. They mapped the surface shapes they could see, assuming that ancient ridges were fundamentally static. But when modern geophysical surveys, airborne magnetics and isotopic zircon dating began looking beneath the surface, the familiar landscape dissolved into a dynamic assembly of ancient ocean basins, inverted tectonic slabs, and active crustal uplift. Much of this landscape remains unresolved. Seismologists at Geoscience Australia continue to deploy portable passive seismic arrays across the eastern highlands to map deep crustal boundaries that remain poorly understood. Biologists are still working to classify thousands of native invertebrate species in high-altitude sphagnum bogs before changing fire regimes alter those microclimates permanently. The official record continues to evolve as satellite positioning updates coordinate frameworks and First Nations place names are restored to topographic sheets. The map appears complete, polished, and definitive, yet the ground beneath it remains restless, complex, and partially unseen. Which geographical anomaly or overlooked landmark in your own state or territory has always struck you as unusual? Tell us in the comments below, and consider subscribing to follow our ongoing investigations into the landscape.